Alrighty, the magnetic compass. Make sure you have your note packets ready. We're going to learn about the compass and some of its errors and how it's used. So, a magnetic compass is required actually by law to be in your airplane. It's the only navigational aid required by law to be in your airplane. Believe it or not, you don't have to have a heading indicator in your airplane, but you do have to have um, a magnetic compass if you're flying VFR. So basically, it's got some sort of fluid chamber in there. So it's floating in fluid, and the numbers are usually on some sort of float. There's all kinds of stuff here, but basically, as it's got a compensating magnet here, and as it's turning through these gears and stuff. It's turning this compass left and right as it's floating in the fluid. This is what we call the lubber line. That's what we used to read off of it, and there could be a compass card in there as well. That's what we call the thing that we actually read. It's got a lens that sort of magnifies it a little bit, helps you see it more clearly. But they kind of look all kinds of different shapes and sizes, but essentially they're right there on the front, either on the dash or hanging from the ceiling. Even if you looked at an airliner, if you ever peeked in the flight deck of an airliner as you go in, you'll see a compass hanging in there. Here's 5 things you should know about the compass. Number 1, it does not require any system really to function properly. It's sort of a self-contained thing. Number 2, it responds to magnetic field that surrounds the Earth. We're going to talk about that a little bit. Variation is a term you should know. This is the difference between the magnetic North Pole and the true North Pole. Believe it or not, compasses, they say, point north. Well, they're pointing at the magnetic North Pole, which is actually a bit different than the true North Pole, where all the lines of longitude come together. So, for example, right here's a line. See if you can see this line right here. This is 11 degrees east. That means that in this area, the magnetic North Pole is 11 degrees different than the true North Pole. So this line of longitude here runs up to the true North Pole, but this line, this purple line here, magenta line, runs to the magnetic North Pole. We're going to learn how to use that in class. Then we have something called deviation. This is when you have forces inside the plane that pull a compass around. So you may have magnetic fields within the plane. There may be magnetized metal. There may be radio frequencies, electrical fields that pull it, things like that. So the compass could deviate, and we call that deviation. Variation, difference between the poles. Deviation is the forces within the plane. I remember variation varies from place to place, whereas deviation always stays the same no matter where you are. This little card down here tells you how the deviation. For example, it says, hey, if you're flying 120 degrees, you should add 1 to that, to those headings that are near that number. If you're flying 150 degrees on the compass, you should minus 1. That's your deviation card there. Then there's this thing called magnetic dip. This is when the magnetic field pulls on the compass card and causes it pulls down towards the Earth. This is called dip error. It's strongest near the poles, and it causes the compass to be unusable when you get up near the magnetic North Pole, which is kind of up in northern Canada somewhere. So as you fly further and further and further north up into the north country of Canada, your magnetic compass may not be as accurate. Essentially what happens, your compass is flying along nice and level and it's pointing at the North Pole, which is way far away. But then as you get closer to the magnetic North Pole, it starts to pull down because maybe it's down here, it's starting to point at it. And then as you fly over it, it could actually point right at it like that. So you get a lot of dip error as we go near it. Yeah. So let's talk a little bit about those errors. There's actually an acceleration error. So if you're on an easterly or westerly heading, so easterly is like 270 is west, 090 is east. So if you're flying on headings near those numbers, so maybe not directly west, you could be going 280 or 250, and maybe not directly east, you could be going 080 or 110 degrees. But somewhere in those kind of east and west sort of headings, if you accelerate or decelerate, it'll swing towards the north or towards the south. Okay? We'll talk more about why that is in class. Go ahead and just write that down. That's one of those ones I just need to explain kind of in person. But if you want to remember the ands way of remembering, meaning when you accelerate, it'll swing to the north when you're on an easterly or westerly heading. And if you decelerate, it'll swing to the south. Okay, so if you decelerate, it'll swing to the south. I think decelerate, does it have 2 C's in it? I don't know. I'll look that up later. So accelerate, north, decelerate south. That's the direction it'll swing when you're on an easterly or northerly heading. If you're already on a northerly or southerly heading, it won't do anything if you accelerate or decelerate. It's already pointing at it, so it's not going to swing. And I'll explain why that is, like I said in class, a little bit more later. Turning error. This is directly related to the magnetic dip we just talked about, and is most pronounced when turning from headings of north or south. So in this one, the other one was east and west errors. This one is a north and south error, but instead of accelerating, decelerating, this is a turning error. And basically you're heading north, and when you turn, it kind of wants to stay pointing at north. So you're turning, and it sort of lags behind you a little bit. And so let's talk about a way to remember how that one is. This one is UNOS. And what we're talking about here is how to roll out on your heading. So I'm turning from a heading of north to a heading of east. I'm gonna undershoot north if I'm turning towards the north, and I'm gonna overshoot south. And we'll talk more about those in class as well. Last thing we're talking about in this lesson is just integrated flight displays. That's this kind of thing we've been talking about, the G1000. I just want to give you some terminology. Since we are talking about flight instruments, this ties into that nicely. First thing we have is the PFD, the primary flight display. That's the one on the left, and it's the one that has all your flight instruments on it, and as well as a lot of other instruments. That's called the PFD. And the AHAR system, that's the attitude and heading reference system. So this is the attitude indicator and the heading indicator. They provide attitude, heading, rate of turn, slip skid information. So that's basically like our gyroscopic instruments, right? We have attitude indicator, we have a heading indicator, and we have a rate of turn and slip skid information. That's like our turn coordinator. So the AHARs is what powers that in that, because it uses sensors like accelerometers and gyroscopes to provide this information, just like maybe our gyroscopic instruments would in a more traditional round dial type airplane. So when you have an AHARS failure, that's what it might look like. So you're flying along, and then you get an AHARS failure, something happens to it, you're going to lose a lot. You're going to lose this type system there. Then we have the ADC, the Air Data Computer. This is more like our pitot-static system, because it gets information from the pitot-static system for the pitot-static instrument. So it's very much related to that. And so if we have a Air Data Computer error, we may lose our altimeter. We may lose our airspeed indicator. I don't know why we're losing these other gauges in this particular picture that I got off the internet, but there you go. Now what happens if the PFD fails altogether? There's actually a button you can push, and you can put the PFD over to the MFD, and the MFD is the multifunction display. It's called multifunction display because it's used for a lot of different things. You can put maps on there, you can put engine information in there, you can put the PFD on the MFD and things like that, but it's the screen on the right side. And I'm not going to go get too much in the weeds on this. I'll show you some stuff in class with it, but there's lots of different stuff you can do on the MFD. A lot of times your engine gauges live over there, so if you're looking at your RPM, your oil temperature pressure, EGT, fuel gauges, electrical system, that's typically on the MFD. Normally, there's a way to put it on the PFD. But yeah, there you go. But here's another view. Like here's the moving map. This one has terrain info on it. But you can plot your courses. You can do lots of stuff on the multi-function display because you can do multiple things on it. Make sure you write down questions in your packets. I'm sure you have tons of questions in there. That's the end of chapter 2. You can ask me anything about flying anytime in class you want. And that is the end of the 4th section of this lesson. Thanks a lot.